Welcome to the online video lecture series of the course Computer Organization and Architecture. In previous few classes, we have talked about various peripheral devices and interfaces, and we have also talked about how the data is transferred from one device to another device. We have also seen various methods through which two devices which are taking part in communication will be synchronized, like stroke control methodology and handshaking, which are used for asynchronous data transfer. So, in today's lecture, we will talk about especially the dynamic memory access control and input output processor, which are controlling the data transfer between I/O device and memory. So, as we have seen, there are three types of transfer, three mode of transfer we generally study in any organization course, that are programmed I/O, interrupt initiated I/O and dynamic memory access control. So, three mode of transfer we have also we have to study in this course. Two we have already done in previous class, that is programmed I/O and interrupt initiated. So, as in previous class, programmed I/O is basically used to control the input output operation between peripheral device or and memory using some instruction or some program is written to control such type of operation. So, detailed discussion we have already done in previous class, and also in case of interrupt initiated like daisy chaining or priority interrupt or any other interrupts we have also seen. So, this lecture is especially designed for dynamic memory access control, the third type of transfer or third mode of transfer, where a controller that is called as dynamic memory access controller, which can control the input output transformation between memory and I/O device. Special controller is used to control the input output operation. Now, you can see what type of signals between CPU and DMA are issued by the CPU. So, in this particular diagram you can see various types of signals are issued by the CPU to inform the DMA, because DMA is the controller which is used to control the input output operation. So, who will initiate the DMA? The CPU, because the overall master of the system is CPU. So, CPU will give a charge to the DMA to control the input output type of operation. So, whatever input output operation or dealing with the I/O device, that will be taken care by DMA, dynamic memory access. So, basically this particular concept or mode of transfer is used to speed up the transfer operation, so that CPU can perform other tasks in parallel to data transfer, because peripheral devices are slower than register and CPU or memory, because these are electromechanical or electromagnetic devices. So, these devices are slower than CPU operation, and to speed up the CPU performance, special controller, that is DMA controller, is used, which can take care of input output type of operation. So, during DMA transfer, the CPU is idle or CPU can perform another task, and DMA controller control the buses. So, obviously, because data transfer is taking place in with the I/O device and memory, between I/O device and memory. So, obviously, buses are required. Buses a type of buses are three types: address bus, data bus and control bus. So, these buses are required in case of DMA control or DMA transfer. You can see in this particular diagram, CPU will communicate with the DMA using these various signals. First is bus request. So, when DMA will take a charge for data transfer, or some device or I/O device is requesting for the data transfer. So, DMA is taking care of this to requesting the CPU please provide the data, please provide the channel. So, these buses are required for data transfer. So, control of buses is requested by the DMA to the CPU using this signal, that is bus request. So, DMA is requesting for the bus to inform the CPU, please provide the channel, and immediately after that the bus grant signal is issued by the CPU in terms of bus grant, providing the command or buses will be in high impedance. Now, DMA will take charge of these buses, or these channels are available with DMA. Now, DMA will perform the operation. There are few more commands you can see. The data bus generally used to transfer the data, and this address bus to transfer the address for particular location of memory, and these read and write signal. These are basically control signals are issued by the CPU to inform the DMA what type of operation, what is the address of starting address of word or data, and read or write operation. CPU want to read something from IO device, corresponding to that read signal will be issued, and CPU wants some storing or to write something in a particular IO device or peripheral device, then accordingly write signal will be issued, and the data bus is used to transfer the data. So, once the BG signal is enabled by the CPU, these buses will be in high impedance, means the control of these buses will is given to the DMA. So, these are the operational signals which are generally used in case of DMA transfer or DMA used by the DMA controller. So, this is bus request first signal, as I said in previous slide. This signal is used by the DMA controller to request the CPU to relinquish control of the bus. So, this is the signal issued by the DMA to request the CPU that please relinquish the channel. So, if this input is active, the CPU terminates the execution of the current instruction and places all the buses into a high impedance state. So, once this signal is issued, BR signal is issued by the DMA, immediately CPU will send the bus grant signal, and all the buses will go on high impedance state. It terminates the CPU will terminate the current execution and provide the channel or grant the channel to the DMA. So, this bus grant signal is issued by the CPU. The CPU activates this output to inform the DMA that buses are in high impedance, you can use it. And now, DMA will take control the buses to conduct memory transfer without processor intervention, because the master or the controller of buses is now a DMA controller, or DMA controller is controlling the buses or using the channel. And when DMA terminates or this transformation operation is over, this signal will be disabled by the CPU. So, when DMA terminates the transfer, it disables the bus request line, because the transformation is over, the communication or data transfer between IO device and memory is over, this signal will go down by the DMA controller. Immediately after that, the signal bus grant will be disabled by the CPU. So, this is again a type of handshaking protocol or handshaking mode of transfer, asynchronous data transfer. So, this way both the devices are properly informed. These two important signals are used in case of DMA transfer. This is the block diagram of DMA controller. It looks like an interface, as we have seen in case of a peripheral interface. It is looking like an interface or internal circuitry, you can see in detail later, but this is a block diagram used to understand the DMA controller, what are the signals and what type of components used in this case. So, you can see there is a data bus buffer. So, whatever data is transmitted or received between CPU and this device will come through data bus buffer. So, this is used for holding the data, whatever data. in case of writing, in case of reading. So, data can be transmitted through this data bus buffer, and these addresses are basically transmitted through address bus. So, for storing the address bus buffer is used, and this address register basically used to store the starting address from where the word count or word or data will be transmitted. Now, next is word count register. How many number of lines or how many number of words are there in each transfer, that can be stored here, or word count register is used for that purpose. And this is the control register used to store various control signals like read operation, write operation, status flag, etc. So, what that type of control will be stored in, or control register is used to hold or store that type of signals. And when this DMA is communicating with the IO device, these two signals are basically used, DMA request and DMA acknowledge. Suppose IO device wants to communicate with DMA controller or wants to inform something with the DMA controller. In that case, DMA request signal is issued by the IO device, and corresponding to that signal, the DMA acknowledgement signal is issued by the DMA controller. Now, you can see this block diagram of control logic, the DMA select signal, RS register select signal, read, write, bus request, BG and interrupt. These are various signals or connections are given in this block diagram. So, DMA selects to enable the DMA or to inform the DMA for data transfer. This DS signal is issued by the CPU to inform the DMA. Now, you can start the input output operation, and corresponding to that, what register is selected? There are 4 type of registers you can see. So, what register is selected using register select? So, that signals are issued by the CPU informing the DMA for data transfer, and if it is a type of read or write operation, corresponding to that, these pins are used, read or write, and read or write signals are issued by the CPU. And once the DMA controller is enabled, the bus requesting for the bus. So, bus request signal is generated by the DMA controller, that is why it is outwards or towards the CPU. There is a CPU, or you can see there is a CPU which is communicating using these signals with the DMA controller. So, this is an interface of or block diagram of DMA controller. So, bus request signal is issued by the DMA controller, and corresponding to the bus request, the bus grant signal is issued by the CPU informing the DMA. Now, you can take a charge of bus, or buses are in high impedance, you can control the buses. And whenever some interrupts are generated by the DMA to inform the CPU to stop the current execution, that interrupt signals are issued by the DMA controller. That is why it is towards the CPU. So, this is the block diagram of DMA controller. The detail of all signals are written here. You can see the first is address register used for direct communication with memory. This address register, suppose the transformation between IO device and memory is to be conducted by the DMA. So, address register is used where addresses are given for particular location of memory. So, this register is used in that case, and word count register which specifies the number of words that must be transferred. So, in each transfer how many number of words are transferred. So, accordingly this value is given in word count register, and the unit communicates with the CPU via data bus. Obviously, data bus is used for communication. So, data transfer between IO device and memory can take place using this data bus, and the register in the DMA are selected by the CPU through address bus by enabling DS and RS. You can see these two signals are basically used to enable the DMA controller or CPU will issue these two signals to enable the DMA controller. Now, you can perform the IO operation, you can take a charge for input output operation. So, these two signals are used, and the BG signal, if it is 0, as I said, BG signal is issued by the CPU, bus grant signal issued by the CPU, and when it is 0, what does it mean, and when it is 1, what does it mean. So, when BG signal is 0, the address bus, data bus and control bus, means channel is using by the CPU, the control of channel is with the CPU, and when the signal is high or it is 1, that means informing the DMA that you can use the buses, or bus grant signal is 1 means the buses are in high impedance. Now, DMA can use these buses. So, that is written here, you can see when BG equals to 0, the CPU can communicate with the DMA register through the data bus to read or write. That means, buses or channels are used by the CPU or using by the CPU. Currently, the bus control is with the CPU or CPU is controlling the buses when this signal is 0. No bus grant is issued, and when BG equals to 1, that means bus grant signal is high or the buses can be used by the DMA, or these buses are to be used by the DMA. In that case, the bus grant signal is issued. So, this is very important. We need to understand when BG equals to 0, what will happen, and when BG equals to 1, what does it mean. So, when this signal is issued means it is high, BG equals to 1 means the buses are in high impedance, DMA can use or DMA can communicate directly with the memory by specifying address in the address bus and activating the read or write control. So, buses are used by the DMA when BG signal is 1, and the DMA communicates with the external peripheral through the request and acknowledgement lines. So, as you have seen, these two lines are basically used to communicate with the IO device. The DMA can communicate with IO device using these two lines, DMA request or DMA acknowledge. So, this is basically a handshaking procedure. So, as we have already seen in previous lecture that what handshaking protocol is, how asynchronous data transfer can take place using handshaking. So, this basically these two lines are used to communicate with IO device. So, this way DMA controller can work. Now, you can see operational concept for DMA. The CPU initializes the DMA by sending the following information through the data bus. Means CPU is giving a charge to the DMA. Now, you can control the input output type of operation. So, what signals or what data is to be issued by the CPU? First, starting address. For reading or writing means suppose CPU wants to read something, what is the initial address or starting address, and suppose CPU wants to write something, what is the starting address. So, read or write signals are also issued by the CPU with the starting address, and the word count, how many number of words are to be transmitted, that are also informed by the CPU. So, word count which are to be given here, and control to specify the mode of transfer such as read or write. If it is a read operation, so accordingly control signal will be issued or will be given here, and if it is a write type of operation, accordingly the write signal is stored here in control register, and control to start the DMA and these two signals. The controls or this device will be informed. Now, you can start the transformation, the CPU will initialize the DMA controller. So, this way we can understand the operation. Now, here it is a DMA transfer in a computer system. How DMA will take place, a transformation operation, how DMA is controlling the input output type of operation. Here you can see these are IO devices or various peripheral devices. This is a memory area and this is a CPU and this is a DMA controller. So, first CPU will generate read or write or some starting address and data, or to inform the DMA you can take a charge of transformation, or you can start the IO operation. So, these buses are used and accordingly controls are issued by the CPU. And to initialize or to start the transformation, accordingly the DMA will be requesting to the CPU by generating this signal, bus grant signal. So, the bus request signal. So, DMA will request for the buses. So, that is why DMA will first generate the bus request signal. Now, please provide the channel, please issue the buses, and corresponding to this bus request, the bus grant signal will be issued by the CPU. So, these two signals we need to understand, these are very important signals which are used to communicate between DMA and CPU. So, bus request is issued by the DMA controller, and accordingly or corresponding to this bus request, the bus grant signal is generated by the CPU. Now, buses or channel is available with DMA. So, buses are in high impedance, once BG equals to 1, buses are in high impedance, the DMA will use the channel. Now, these buses are available with DMA controller. Now, whatever data transformation is to be carried out, that will be controlled by the DMA. If it is a read type of operation, so read operation will be taken care by the DMA, and if it is a write type of operation, then it is also be taken care by the DMA. So, this way DMA will work or will control the input output operation in the system. One more type of transformation is controlled by the input output processor. So, we can also use the input output processor, which is used to control the input output operation, or that processor can also be used to control these peripheral devices which are taking part of which are used for input and output type of operation. So, in place of DMA, we can also use such type of controller, so or IO processor. So, in short, or it is abbreviated as IOP, input output processor. So, the IO processor is very similar to the CPU. It can also perform input output operation or control the input output operation, and also perform some execution of instruction. So, it is very similar to the processor, or you can see one more processor is attached with the system which can control this input output operation with the peripheral devices, as well as small instructions can be executed by the processor. So, unlike DMA, because in case of DMA the CPU is controlling the DMA first to initialize the DMA. Now, you can start the DMA and it can perform only input output operation, but the IOP device can also execute or fetch and execute some instructions. DMA which cannot be done by DMA. DMA can perform only input output operation. However, this IOP can perform some fetch and execute type of operations. So, that is why it is different with the DMA. It is totally different with the DMA. However, once it is controlling the input output operation, it will work as a DMA controller. So, you can see the DMA and IO processor will be very similar if both the devices are doing one operation, that is input output operation. However, IOP can perform some other type of operation, fetching and execution of instruction like arithmetic operation. The IOP can perform other processing tasks such as arithmetic and logic, etc., and provides a path for transfer of data between various peripheral devices and memory. Obviously, so it is very similar to the CPU or processor. It provides a path between memory and peripheral device. This is memory and peripheral device, and it can execute some type of operation, mathematical or logical operation. Or you can see communication between IOP and devices similar to the program control. As we have seen in case of program control, this communication will will look like very similar to the program control, means some instructions are written to control the program, or some programs or some flow chart is given to control how this transformation will take place in case of IOP with the peripheral devices. Now, these are few steps or algorithm written here, how this IOP and CPU will communicate each other, and what type of communication is done between IOP and CPU. The CPU sends an instruction to test the IOP path, that is written here. First, it will send a signal to the IOP or for testing the path, and the IOP responds by inserting a status word in memory for the CPU to check. Accordingly, it will inform the CPU. Now, the bits of the status word indicate the condition of the IOP and IO device. So, these are the bits issued by the IOP that devices are ready and the current status of the particular IO device. Busy with another transfer or device is ready for the IO transfer. Suppose CPU wants to communicate with some device. So, that status or the status of particular device is issued by the or informed by the IOP. Next, the CPU refers to the status word in memory to decide what to do next. If all is in order, the CPU sends the instruction to start IO transfer. So, this way the CPU will continue the work, and the memory address received with this instruction tells the IOP where to find its program. Next, the CPU can now continue with another program while the IOP is busy with the IO program, and both programs refer to memory by means of DMA transfer. Next, in next step, when the IOP terminates the execution of this program, it sends an interrupt request to the CPU, and the CPU responds to the interrupt by issuing an instruction to read the status from the IOP. So, that is written here. You can see the IOP responds by placing the contents of its status report into a specified memory operation. So, these are important steps you can read out or you try to understand through this flow graph the operation between IOP and CPU. So, in this particular lecture we have seen how DMA controller and IOP can be used for input output type of operation with peripheral device and memory. The third type of mode for data transfer that we have seen in this particular lecture. So, in next lecture we will discuss some more operations of IOP and other remaining part of this course. So, that is all about this lecture. Thank you.